Hello and welcome to today's video. So on the workbench today we have a Brusa NLG513, serial number 188. And this is not mine, it's customers, it's in for repair. Apparently, well, it was coming up with a error message that the power stage was shorted. So I went ahead and took the whole thing apart. And of course, after doing a diode check and checking all the MOSFETs, or the IGBTs, everything was fine. So I could not find anything that was shorted on it. Sent a quick email off to Brusa's technical support, long shot kind of a thing, saying, hey, you guys got a schematic, or is there anything that if you've got this error message that it could be? And of course they come back with, there's no user serviceable parts inside, do not open it, send it in for repair, and they want you to mail it to Switzerland. And yeah, so they were extremely not helpful at all. So what I did is took the cover off, I powered it up, still put it all back together, powered it up, was still getting that power stage shorted error message. And one thing I noticed is I powered it up with the case off, and it's got all these little LEDs. Here, let me turn the light off here, you can probably see them better. So there's little LEDs for all the power supplies, and the one down here, 15 volt power supply, was not lit. It was dead. You might see there's a capacitor missing, and that's the capacitor. Now, of course, it wasn't burned, so it looked just like all these other ones. But with the power supply shorted, I couldn't get it to actually power up, or I couldn't get it past that error message. But if you look down in here, right above there, it's probably hard to see. Let me turn the light back on. Does that help? Yeah. See that 15 volt right next to the LED? Yeah, so what I did is I did a little ohming out. I have no idea what could have been shorted on the 15 volt supply, because there's a whole bunch of stuff in here. I don't know what's on there. But this is ground, marked ground, and I had 15 volts here. Well, I didn't have 15 volts there. So I actually hooked it up to my my big power supply, because I knew there was a short somewhere. I could measure across this cap bank, which is the cap bank for the supply. You can see it comes out. There's a fairly large diode down there. It comes out of the output of this transformer right here, this planar transformer. You can see that's the diode for this little power supply, and apparently 15 volt supply is used to generate all these little supplies down here that go off to the power stage. In the board below, you can see all of these little guys down here is generating all the individual power supplies. And up here. So this 15 volt supply is the intermediary supply that runs all of this guys, which goes down to the bottom layer board, which runs all of the IGBTs down there. So obviously it's thinking that power stage shorted because, nothing was happening, and that was because it wasn't powered. So what I did is I hooked up my power supply, my my X-Tech power supply, to here, and I put the current limit at about an amp, turned it on, dead shorted. Cranked it up to 2 amps, still dead shorted. 3 amps, still dead shorted. 4 amps, the magic smoke finally came out of this capacitor. Yeah, it started smoking pretty bad, and sure enough, if you were to measure this capacitor, it is still a dead short. I can't do that right now because my meter's down on the floor here, which I'll show you in a second. So after unsoldering that, boom, the 15 volt supply is back up and running. Everything's good. So I will go ahead and replace that cap. I don't think it died electrically. I think it died mechanically. If you notice, there's this little block here where this cable comes through, and you can see there's a hole there, and there's a hole underneath here where that zip tie is supposed to go through. And I think this guy's been rattling around in there and was impacting that corner, because if you look at where the smoke came out, that's this upper corner here, and I think that was the corner that this guy's been rubbing on, and I think that's actually caused it to mechanically, it had too much stress on it, and mechanically that eventually caused it to fail. So I don't think any of the other ones are bad. Like, all the other ones look fine. Even now it's running fine on with one missing, but I'll go ahead and put that back in, because it probably works fine at room temperature, but if it got really cold, the capacitance would drop, and it probably won't be able to regulate that 15 very well. So I'll go ahead and replace that. But anyways, we'll go ahead and fire this thing up. Now, of course, it's pretty smart. Let me turn the light back off here. So right now we've got an error because my battery is undervolted, and of course I don't have a big enough battery. So we're using the good old capacitor of doom to kind of simulate a battery because it won't. So I'm going to turn this up here, and we'll crank that up. So hopefully you can see. I don't know if you can tell on there, but kind of 190 volts. This thing's actually programmed to do 275, I think. But this is enough to trip it into thinking, hey, everything's cool, we're good. I've got it. So yeah, it's reading 190 volts on the meter there, and on their monitor program we're reading 189.8. So yeah, it's pretty good. Excuse me. Oh, let me show you the so if we go over to status, I think, is it status page? Nope, errors and warnings, that's what it is. So we go over to the errors and warning page, if we get it to focus here. The short circuit power stage right here is the one that had error. But you can see now everybody's okay, everything's good. So go back up to the main monitoring page again. And maybe if it'll focus, there we go. So I'm going to go ahead and command it turn on. It's pretty simple. We're just going to flip this switch, and it's going to rapidly go through all of its things really fast. So here we go. You'll just see the lights get a little bit brighter. Well, a lot brighter, but I don't know how it'll show up on the camera. You ready? Set. So we're now running, and if we go really quick, the battery is now fully charged because obviously I don't have a battery hooked up, and we're just powering a bunch of light bulbs. We're up to 250 volts. So the battery charger is working. And yes, this is the sketchiest setup on Earth, so don't replicate that. If we come over here, you can see everything's working, 250 volts. We're putting out 2¼ amps now. Everything else looks fine and happy. If we go over to the errors and warning page, you can see everything is still happy and running. And if we go to the status page, you know, everything is totally happy. Everything's good. So I would call it fixed. A single capacitor was bad and causing the whole thing to not work. So anyways, yeah, it's up and running. So ta-da! Let me know if you like the quality of this video better. I have a new cell phone, and so hopefully I am still learning it, so there might be some things. I wonder if I can do this. Can I actually flip this while it's right? Oh, I can! Look! I got wide angle. That makes my bench look horribly messy. We'll go back to normal. I can turn the light on and off. My other one wouldn't let me do that. So I got a LG G6 phone. So yeah, I like it so far. It's pretty nice. It's got manual focus, but I think that's only for pictures. I don't think I can do manual focus while I'm doing a video. But anyways, yeah, this is up and running, 250 volts. Yeah, I can probably even turn this thing down and it'll keep on going. See? Because it's running off the battery charger. So yeah, so I'll go ahead and flip the switch off here, and it should drop out pretty quick. You ready? Boom. So yeah, everything's working. So yeah, I'm quite happy with this. I'll go ahead and see if I can get another one of these caps here to put in there, and button it all back up, and ready to ship it out. So it looks like everything's working. Thanks for watching. Bye.